class. Today we will discuss on the following objectives. The objective would be the Langrangian descriptions of the strains. We have studied the different definitions of the strains. The various definitions of the strains were the engineering strains, the true strain, the natural log strain, Langrangian strain and the Eulerian strain. Among all these five different definitions of the strains, the engineering strain and the true strains comes under the linear strain definitions, whereas the natural log strain, Langrangian and the Eulerian strains deals with the large strain problems and comes under the definitions of the nonlinear definitions of the strains. Strain in terms of the Lagrangian descriptions, these deformations whatever we will be discussing will be always with respect to the initial configurations. So here we can see a figure. This one is in the three-dimensional Cartesian coordinate systems with the coordinates axis being x-axis, y-axis and z-axis. The initial configuration is denoted as t is equal to 0, which is shown by the bold line. So this one is the line shown by the line sketch drawn by the bold lines is the initial configurations, and at time t is equal to t, under the actions of the different types of the forces, it get displaced to a new positions which is shown by the dotted lines. So the point A over here lies on the initial configuration. So this point A lies on this reference of a body which is under the undeformed configurations, and the point A dash, this point A dash lies on the deformed configurations which is after time t is equal to t. The initial position vector of point A is given by r, and the initial and the final position vector is defined by r dash, which represents the point A dash, and u is the displacement vector. So here it is written like at t is equal to 0 represents the initial configurations. So this is the state. At t is equal to t, it is the displaced configurations which is shown by the dotted lines. R dash is equal to r dash bracket r comma t. This means that the deformed configurations is with respect to the initial configuration. So whenever we are defining in terms of the Lagrangian descriptions, we will always refer to the initial configuration, the initial state of the body. So u dash is the displacement vectors. Now how we will define the u vector? U vector will have three components in it, u, v and w. So u vector is defined by ui plus vj plus wk, and now the u vector again is given by the position vector r dash minus r vector. So the u vector, which is the displacement vector, it is given by r dash vector minus r vector. Now we need to define the deformed state of the body, the coordinate systems. So the coordinates x dash, y dash and z dash lies on the body at time t is equal to t, which is shown by the dotted lines. So the displacement with respect to the initial coordinate system is given by x dash is equal to x plus u. Over here x represents the initial state at time t is equal to 0, and it has undergone a displacement of u in the x directions. Y dash is equal to y, the initial coordinate of the body and v is the displacement it has undergone in the y directions. Similarly, the z dash represent is equal to the initial coordinates plus displacement it has undergone in the z direction. So we have defined the displacement vectors as well as the new coordinates under the deformed configurations, which are x dash, y dash and z dash. Now we will use the chain rule of differentiations to calculate the small displacement, this dx dash in x direction, dy dash in y directions and dz dash in z direction. So how we can calculate the values of dx dash? By using the again the partial derivative. So we can calculate the values of dx dash by partial derivatives of x dash with respect to x plus partial derivatives of x dash with respect to y and the partial derivatives of x dash with respect to z. Similarly, for the dy dash, it will be partial derivatives of y dash with respect to x, partial derivative of y dash with respect to y, and the partial derivatives of y dash with respect to z. Similarly, dz dash is given by partial derivatives of z dash with respect to x, partial derivatives of z dash with respect to y, partial derivatives of z dash with respect to z. So now we need to relate the final displacement dx dash with respect to the initial displacement, which is dx dy dz. So if we rearrange the terms, all these three equations that we have got, the first equations, the second equations and third equation, let us try to bring it in the matrix forms. So we will represent it by, this is the terms related to dx, dy and dz, which is represented over here. Now we will take out dx, dy and dz from all these equations, dx, dy and dz from this equations, dx, dy and dz from all these equations, which is shown over here. Then we will be left with a matrix. So this one is the matrix with which we will be left with, and this matrix is known as the displacement gradient. Why it is known as the displacement gradient? Because it is x dash, y dash and z dash. This x dash, y dash and z dash are the displacements, and we are calculating differentiating it with respect to x. So it is actually the, this matrix is the displacement gradient matrix. So the advantages of putting it in the matrix form is that it becomes easier to handle. Now we need to define the strains. The strain is defined by strain in PQ plus 1 by 2 strain PQ whole square is equal to 1 by 2 ds dash whole square minus ds divided by ds. So ds dash is the final length, ds is the initial length and ds is the initial length. So in case of the Langrangian descriptions, it is always with respect to the initial configuration. The length in the initial configuration is given by ds. So we need to calculate the different values. The different values are ds dash and ds. So it will be ds whole square. Here also it will be ds whole square. So we will first calculate the values of ds dash whole square. So how can we define ds whole square in terms of, it will be in the terms of x, y and z, because we are working in three-dimensional space. So ds dash square will be dx dy dz multiplied by again dx dy and dz star, or you can say dz primes. So we have calculated all these values. These values we have calculated with respect to the initial coordinate systems. So what are these values? These are actually these values. So this one is dx prime, dy prime, dz prime, which is equal to this matrix multiplied by dx dy dz. So we will put the entire values over here, put the entire values, these entire values over here. Then finally we will get the values like dx dy dz multiplied by the f matrix, that's transpose, multiplied by the f matrix multiplied by the dx dy and dz. So what is matrix f over here? So this is the matrix. This matrix is referred as the F matrix. Now we have calculated the first part, which is d dash whole square, which is the length under the deformed configurations. The next part would be to calculate the values of ds square, which is the initial length. And if we calculate the values of initial length, then we would be in a positions to relate the strains, the linear part of the strains and the non-linear part of the strains with respect to the displacement in x direction, y direction and z direction. So our next motive would be to calculate the values of ds square. So what will be the values of ds square? Ds square will be simply multiplications of dx dy and dz multiplied by dx dy and dz. Why dx dy dz not prime? Because this one is the displacement in terms of the initial configuration. Now we have calculated the values of ds dash whole square and ds whole square. If we will rearrange the terms, we will finally get up with the equations of this forms: dx dy dz multiplied by f transpose f minus the identity matrix multiplied by dx dy dz. Now there is a notation that is given to f transpose f. This f transpose f is represented by letter G, and this tensor is known as the green strain tensor. This thing you have to keep in your mind, that f transpose f, which is the displacement gradient, is given by a letter G. That G is known as the green strain tensors. Now if we take out these two values to the LHS, again what is this value? This value is ds square. So if we subtract it, if we divide it with ds square, we will get the definitions of the strain that is in RHS. So this terms ds dash whole square minus ds square is known as the is denoted by the letter L, and this L is known as the Langrangian finite strain tensor. So the Langrangian finite strain tensor is given by 2L is equal to F transpose F minus the identity matrix. Now we need to refer it back to the initial coordinate system. The F matrix is in terms of the deformed configurations. So this F is dx dash dx, dx dash dy, dx dash dz, dy star dx, dy dash dx, dy dash dx dz dz star dz dash dx dz dy dz partial derivatives of z with respect to z, and we have already defined the terms x dash which are the which relates the deformed configurations with respect to the initial configurations. So x dash is equal to x plus u, y dash which is the deformed state, y dash is equal to y plus v, and z dash is equal to z plus w. Now what we need to do is put the values of x dash. This values of x dash will go everywhere. It will go over here. This x dash value will go over here. This x dash value will go over here, and we will partially differentiate it with respect to x, partially differentiate it with respect to y, and partially differentiate it with respect to z. Similarly, this values of y dash will go over here. This values of y dash will go over here. This values of y dash will go over here. Again, we will differentiate it, partially differentiate it with respect to x, partially differentiate it with respect to y, and partially differentiate it with respect to z. The next step would be to put the values of z dash. Z dash will go over here. Again, this value of z dash will go over here, and the values of z dash will go over here. Again, we will partially differentiate it with respect to x, differentiate it with respect to y, and differentiate it with respect to z. Finally, when we put these values of x dash, y dash, and z dash and differentiate it with respect to the x, y, z, we will get the values of f is equal to this value, this stress vector, this values of this matrix plus the identity matrix. This matrix is known as the denoted by the J matrix, and this matrix is denoted by the I matrix. So finally we have brought up it to the initial coordinates. The initial coordinates are x, y, and z. So from this equations, which we know, 2 multiplied by L is equal to F transpose F minus I. We have calculated the values of F. The values of F is equal to J plus I. Now we need to put the values of F over here. Its transpose, the values of F over here. So we will put the values of F over here. So when we put the values of F in this, we will get I transpose plus J transpose. This is for this values has come from this F transpose, and I plus J, it is for F minus the identity matrix which is given as it is. Now we will multiply these terms and rearrange these terms. Finally we will get up with I plus J plus J transpose plus J transpose J minus the identity matrix. Now we will rearrange these terms, and finally we will get the Langrangian definitions for the strain, which is known as the Langrangian, represented by letter L, is known as the Langrangian finite strain tensor. If it will give us 1 by 2 multiplied by J plus J transpose plus 1 by 2 multiplies by J into J transpose. Over here, this terms is known as the linear terms, and this terms j multiplied by j transpose represents the nonlinear terms. Why? Because these are in the multiplications and this one is in the similar linear combinations. So this one is the linear terms and j multiplied by j transpose is the nonlinear terms of the Langrangian finite strain tensor. So the learning outcome of this session would be, we have studied the definitions of the strains in terms of the Langrangian descriptions. So whatever we have calculated, the values of the strain which we have calculated on the basis of the initial configurations, which is the undeformed configurations. So this is all for this sessions. We will meet you in the next sessions. Thank you.